Hello, I'm Edward Tart, a math teacher. This is another in a series of solution videos for some of my math challenges. This particular challenge is entitled Sequence of Positive Integers, and here is how I presented that challenge in the original video. We have a sequence of numbers. Every number in the sequence is a positive integer. Positive integers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on indefinitely. This sequence goes on indefinitely. Every positive integer is in the sequence. For example, this positive integer is in the sequence. After the initial 1, every number in the sequence is equal to or greater than the number immediately preceding it. For example, this 3 is equal to the number right before it. This 4 is greater than the number right before it. Every integer n in the sequence appears exactly n times. For example, the integer 3 appears exactly 3 times. The integer 37 appears exactly 37 times. This integer appears exactly this many times. Notice the first appearance of the integer 4 is in position number 7. That is, it is the first, second, third, fourth, fifth, sixth, seventh number in the sequence. And now we're coming up to the question. This integer, 1713, has its first appearance in the sequence in position number k. What is the value of k? Here's my solution. We are concerned with the integer 1713, the location of its first appearance in the sequence. Well, our task to begin with will be to determine how many positions are filled leading up to that integer. That is, from 1 through 1712. Well, the integer 1 appears once, the integer 2 appears twice, the integer 3 appears 3 times, the integer 4 appears 4 times, and so on up to the integer 1712, which occurs that many times. So we must find out what all those integers add up to. Well, that's too many integers to just add up. We need to look for a shortcut. And fortunately, there is a very useful shortcut. The first and last integers, 1 and 1712, add up to 1713. Working in from the left end and from the right end, 2 and 1711 also add up to 1713 because there's a gain of 1 at the low end and a loss of 1 at the high end, which balances out. And again, as we continue to work our way inward, each pair adds up to 1713. So we have a bunch of pairs of integers, each pair adding up to 1713. How many pairs are there? Well, there are 1712 integers in all, so there are half that many pairs. That means there are 856 pairs. So we're talking about 1713 times 1712 divided by 2. That's 1,713 times 856, which is 1,466,328. So there are that many positions filled by the integers 1 through 1,712. And so the next integer, 1,713, makes its first appearance in the very next position, which is position number 1,466,329. So that is my solution to my sequence of positive integers challenge. Thank you for watching this solution video.